Hello. So in this segment, we are going to be computing a rational function. So looking at this thing, oh my God, right? Like, wow, that sure is a lot of symbols. So first step, don't get intimidated, right? Just do this one step at a time, one little term, one piece at a time, and just sort of chug your way through it, okay? So here we have this f of x thing defined. We have that we want to plug in 0, right? We want to compute f of 0. So the first step is basically rewriting this whole thing, but everywhere we have x, we're just going to put 0 in parentheses, see what we get, okay? So f of 0 equals, all right, here we go. So in the top we have negative 3 times plug in x plus 4, close parenthesis. Then we have square root of, right? Next up, absolute value, negative, plug in 0, minus 2. That is in the absolute value. And then that closes off the square root. Okay? Next up, we have log of, and then we have absolute value, 2, input our x, right? Minus 1, that closes our absolute value, plus 1, and that closes parentheses, right? So just go through it one piece at a time, slowly but surely, right? All of this over. Same deal on the bottom. So here we have open parenthesis, e to the 3, and then our x, plug in 0, minus 1, all minus 1. And I want to try to make the ones a little obvious, at least in this first part. Then we have square root of, absolute value of, right? I really am just looking at this sort of one scene at one sort of symbol at a time, just going slow but sure. 4 times input x plus 3, close my absolute value, then that is all of the square root. And then I have another absolute value, minus, plug in x, minus 3. All right. So I plugged in all my x's. I went one symbol at a time. I've gone one step. I'm going to do the same thing again, but I'm going to try to sort of simplify by just looking at one term at a time, right? So looking at that first bit here, I have a negative, open. I have 3 times 0, that's just 0, plus 4. So I have a 4, right? I've done this term. In fact, if it helps, as you do them, you can sort of check off, like I did the negative, I did that term, right? Next up, I have square root. So I have absolute value of, negative 0 is nothing, so that's just 0. Minus 2, so I'm going to have a negative 2, close my absolute value, and that's the end of my square root. Okay, so I've done the square root. Then I have log. So I have log of 12 times 0, that's just 0. 0 minus 1 is, oh, sorry. See, this is why one symbol at a time. Log of absolute value. 12 minus 0 is 0, minus 1 is negative 1. Close, plus 1, close. So that got that term. Okay, so I've done all my top terms. Now let's go to the bottom. So here, open parenthesis, e to the 3 times 0 is 0, minus 1. That's e to the minus 1. Minus 1. Close. So that's got my bottom term, or the first bottom term. Then square root of, open my absolute value, right? So this is a square root of 4 times 0 is 0, plus 3 is 3. Close the absolute value, close the square root. I have open, so that means I'm done with that one. I have open absolute value, minus 0, again it's 0, minus 3, so that's a negative 3. And I got that one, okay? Now there is a little bit more I can do, although not a lot actually, because, right, we want exact answers, and e to the minus 1, that's actually as good as it gets, right? I can't do much with that, right? But I can sort of evaluate the absolute values where they're just numbers and sort of clean it up a little, but it's not going to change a lot, right? And in fact, if it helps, you can sort of, maybe in a different color to make sure we don't think of it as rewritten yet, but we can sort of say, okay, this isn't going to get any better, that's not going to get any better, right? Like negative 4 is negative 4. But everything else basically has an absolute value somewhere we can get rid of, so we're at least going to do that. Okay, so I have in the top a negative 4. That gets rid of these. And I have square root of, here absolute value of 2 is just, absolute value of negative 2 is 2. And then I have the absolute, and then I have the square root around it. So that got rid of that base. Then I have times log of, absolute value of negative 1 is 1, plus 1 is 2. So I have log of 2. So that got rid of this piece. And that's the last of the top. So I go to the bottom. Here, that e to the minus 1, right? I got that part. Absolute value of 3 is just 3, so that's going to be the square root of 3. I got this part. And absolute value of negative 3 is 3. I have times 3. And at this point, like, there are ways of making this look prettier, but this really is as sort of a perfectly fair, simplified version. So I could definitely say, you wanted me to compute the thing, here it is. I have computed it. Just so that you have seen it, right? It's possible, for example, on a like multiple choice exam or something, you might need a different format. What you could do is sort of group like terms together as their own sort of multiplying term. So for example, we have negative 4 over 3. So we could have that as negative 4/3, right? Square root of 2. So again, I'll maybe check these off as I use them to make sure I use everything correctly. Square root of 2 and square root of 3, I can merge those into one square root. So that becomes square root of 2/3. And the last pieces, they don't combine with anything, so I'm just going to put them in one last fraction. Log of 2 over e to the minus 1 minus 1. So like this is another way that you could actually have that thing be written. But to be honest, I actually sort of prefer that this way. Maybe like with the 3 in the front, or the 3 and square root of 3 at the lead, right? So it's like 4 over 3 root 2 over root 3, log 2 over, e to the minus 1 minus 1. But I wouldn't actually break it up into different fractions, personally speaking. But these are mathematically equivalent. So whichever one you sort of like more, you can write it in that way. That is fine. The important thing is that you need to be able to recognize different formats or move from different formats as needed, by somebody else. Someone else needs you to do it, like for an exam choice or something. Then you need to be able to go from one to the other. Okay. But otherwise, that is that. Hello. So this video, we are computing a rational function and just sort of looking at this monster, right? A lot of terms, but sort of first step, don't get intimidated. Just do it one term at a time, piece by piece. Plug in the x value that it wants. Here it wants you to plug in 1. So just term by term, rewrite everything unless it's an x, then plug in what that sort of x value is, in this case 1, and chug your way through, right? So here, just starting, I'm going to have f of 1. So first term in the top, I have open paren, so 4x, where x is 1, minus 3. Then I have open paren x, so that's 1, minus 4 cubed. Then log of absolute value 3 times x, where x is 1, minus 1, close absolute value, plus 1. I like to make my ones a little more fancy when there's an absolute value nearby, so I can tell which one is the absolute value and which one is a 1. Just in case they get sort of the same height, I don't want to get confused. All right, so that was the top piece, right? Just one term at a time, plugging in x where I need it to. Bottom, I have open paren x, that's a 1, minus 3, and then log open paren absolute value 4, x is 1, plus 4, close absolute value. I'm going to make that into a fancy 1 so I don't get mixed up. Plus 1, close paren, and then log open paren absolute value minus 2 times x, where x is 1, minus 3, close absolute value, plus 1, close paren. Okay, so one piece at a time, right? So now we're going to do that again, one piece at a time. So in the top, I have 4 times 1 is 4, minus 3 is 1. So in parentheses, I have 1. And I can help, if you want, you don't have to do this, but it can help sort of check off the ones that you've done, right? This next one, I'm going to have 1 minus 4, that's negative 3 cubed. And then I'm going to have a log of absolute value of, let's see, 3 times 1 is 3, minus 1 is 2. Close absolute value, plus 1. I forgot to do this as I went, so I did this one. That was minus 3 cubed. I've now done that one. All over, I'm probably going to need a longer line, but that's okay. 1 minus 3, so that's negative 2. Again, one term at a time. Don't look at everything and get intimidated. And I have log open. 4 times 1 is 4, plus 4 is 8 in absolute value. Again, I should make my ones a little more fancy so that I can tell. So plus 1. So that was that term. And then my last term, open paren, so absolute value. So 2 times 1 is, negative 2 times 1 is negative 2, minus 3 is absolute value minus 5, plus 1, close paren. That longer if I need to. Okay, and that was that term. Continue on my simplification binge here. So 1 times something does nothing, right? So I can just, I don't even have to write anything to claim I've done that. Negative 3 cubed, so this is negative 27. So far, so good. Log of absolute value of 2. Absolute value of 2 is 2, plus 1 is 3. So that's going to be log of 3. Over, to be clear, negative 27, that was from there. Log of 3 is from here. And on the bottom, I have negative 2. That was this. And I have log of absolute value of 8 is 8, plus 1 is 9. And then I have log of absolute value of 5. Negative 5 is just 5. Plus 1 is 6. Sorry, I forgot. I keep forgetting to do this. So that was for log of 9. This is log of 6. Now, strictly speaking, I have computed it, and it's basically at its sort of simplified-esque form. So I could stop here. However, we do know how to combine some of this stuff. So I'm going to go sort of one more step just to show that there are sort of ways of making this a little bit nicer. Generally speaking, unless there's some sort of really nice thing coming out of it, I don't usually bother putting coefficients up as powers using log rules. Like here I have 2, so maybe I would do that to do some sort of like move the 2 in and square the result if that looked nice. But like 3 to the 27th power, no, right? I don't want to deal with that, not at all. Right, so, and as it turns out, what I'm going to get here, same sort of issue. I don't want to do anything with that. So unfortunately, there's not sort of a lot I could do here. I guess, like, again, to be clear, I want to make sure that I don't mix up my log rules, right? So like off to the side, I could write them to remember. I have stuff like log of AB, that is log of A plus log of B, right? And I'd be like, okay, do I have something like that? Well, I mean, I could do something like that here, but the problem is that that makes an addition, right? This is multiplying outside, whereas I would sort of need it to be adding outside so that I can make it multiplication inside. So there's not a lot I can do with that. Same to be said for doing, I have that, right, log of A over B is log of A minus log of B. So again, sort of if I'm thinking like division, it doesn't quite work out the way I want. So really, the only thing I can sort of actually do here is I could put the powers up or not. So in the top, I could do something like negative 27 log of 3. And the bottom 2 is sort of reasonable enough that I could actually do something with that. So I could do something like, so again, to be, I guess, I was going to do this in the next step, but I don't want to write another step. So the other thing I'm going to notice, right, is that, that's terrible. The other thing I'm going to notice is that I have a negative over a negative, right? So I can cancel those. So I have 27 log 3, and then I could take this 2, and because it's multiplying both, I could do either one, right? So I could do this as log of, let's say 81, log of 6. So this is a thing I could do. Likewise, in the bottom, I could also have instead, right? If I move the 2 over to the other one, I could have log of 9, log of 36. These are also the same thing, right? Because the 2 is coming up as a power, and I could either put it a power here to get 9 squared or here to get 6 squared. Another thing I could do, again, if I really wanted to, is I could think about the division of logs as being a change of base formula, right? So this is, for example, log base B of A is log base C of A over log base B, base C. Base C of B. And I mention this because, as it turns out, I can do something here that actually does honestly make it nicer, but it's super not obvious, right? So I'm going to show you this, but know that I don't really expect you to be able to see this necessarily. Because what I can do is I can take, for example, this bit here, right? So I can look at log of 3 over log of 81. And think of it like this, right? Because they're both, say, log base, really whatever, they're the same base. So let's say log base 10 of A over B. So that means 3 is A and 81 is B. That goes here. So this is like doing log base 81 of 3. And you might say like, okay, why do I care? But I care because 81 is actually 3 to the 4th, which means I can look at this as log base 81 of 81 to the 1/4. And here the log and the base cancels, so that's really 1/4. Which means if I had it like this, right, and this is the ... rabbit out of a hat, right? Like, again, I would have been fine stopping here. Like, if that's your answer, cool. I'm just showing you that, like, this is one of those things where it is actually hard with, especially with things like logs, to see how to get from one sort of format to another. So here I could have 27, convert these into log base 81 of 3 all over log of 6. And here, right now, I can't do another change of base on account of the fact that these are no longer the same base, right? But I just showed that log base 81 of 3 is really just 1/4. So that means I can replace this with 1/4, meaning that I really have 27 over 4 log of 6. All right. So this is the craziness, right? As I can go from here to here, and that seems like it's completely insane. But it's not, right? You just have to be somewhat clever with change of base, and then you can get there. Okay. So again, one more time, just to be clear, this, totally happy with that, right? So I don't expect you to do this. I just want you to be aware, like, this is a thing. All right. So that is that. Hello. So in this video, we are calculating a rational function. So as is often the case, looking at this, it's kind of intense, right? Lots of terms. So just tackle it one at a time, plugging in the x value, right? The -1. Wherever we see an x, just one term at a time. Don't get intimidated. All right, so let's roll. So we want f of -1. Okay, so starting at the top here, I have open paren 2 times x, that's -1, minus 3 squared. Okay, open paren x, which is -1, plus 4, square root of absolute value of -3 times x, which is -1, minus 4, close absolute value, close root. Okay, so that's one term at a time, got across the top. Now let's do the bottom. All right, so bottom I have 2, open parenthesis, 3 times times x, which is -1, plus 1, all squared. Then I have x, which is -1, minus 1. And I have absolute value, x, which is -1, plus 3. Okay. So I've plugged in all my x's. Now let's go ahead and compute. Again, one term at a time. Don't do anything crazy. So 2 times -1 is -2, minus 3, that's -5. I'm going to want to square that. And again, if this helps, you can do this. You don't have to. I'm just going to mark off that I've done that term now. Then -1 plus 4, that's just 3. That's this term. And then here I have square root of absolute value of negative 3 times negative 1. So that's 3 minus 4 is negative 1. Close absolute value. That was that part. So I've got my top done. Bottom. 2. That's easy enough. I got that part done. Open parenthesis. So 3 times negative 1, that's negative 3, plus 1 is negative 2 squared. Minus 1 minus 1, so that's minus 2. Sorry, this was the minus 2 squared. That's the other minus 2. And then I have absolute value of minus 1 plus 3, so that's going to be 2. Lots of 2's in the bottom there. And that's that. Okay, so now I'm going to try to clean this up a little. So negative 5 squared, that's going to be 25. 3 is just 3. Square root of absolute value of negative 1 is just 1. Over. So I guess I should mark these two. So negative 5 squared is 25. 3 stays 3, and radical, right, 1. Then I'm going to have a 2, stays that way, 2. The negative 2 squared, that's just positive 4, times negative 2. And then absolute value of 2 is also just 2. Now I have a whole bunch of numbers, so I'm going to combine the numbers together. So 25 times 3 is 75. So 75. Square root of 1 is just 1, but multiplying by 1 does nothing. So I'm just going to, that just doesn't do anything, right? So that got rid of 25, 3, and multiplying by 1. In the bottom, 2 times, right, I can do it in any order. So we're going to do 2 times 2 is 4, times another 4 is 16, times negative 2 is going to be negative 32, which just to make it look a little prettier, I'm going to pull a negative out. So it's negative 75 over 32. There is my answer. Okay. So again, just, right, it looks very intimidating to start with, but just tackle it one term at a time, right? Plug in the x one piece at a time all the way through, and just do sort of narrowing it down whatever level you can, one piece at a time, one step at a time, until eventually you get down to just your number. Okay, so that is that.